Good evening, children. Today let us see new chapter in chemistry, that is organic chemistry, some basic principles and techniques. In this, I am going to teach three topics. They are general introduction and classification. This is one topic, and then nomenclature of organic compounds, and that is followed by IUPAC nomenclature. Now let us see the first topic, that is general introduction. Majority of the substances which we are eating are organic compounds, except sodium chloride, NaCl and H2O. The remaining things which are entering in our stomach, which we are eating, which are associated with good calorific values, are nothing but the organic compounds. Right? And here, as and when the concept of organic compound is taken, we should know about carbon. Because without carbon, there is no organic compound that exists. And valency of carbon is 4. So it is said to be tetravalent. Next important point is, carbon is able to form bonds with other carbon atoms by sharing electrons. Right? This is called catenation. In class 10th, this topic was taught. Right? Next, carbon can also react with the elements like nitrogen, oxygen, phosphorus, sulfur and halogens. Right? So, organic compounds mainly will have three elements: carbon, hydrogen and oxygen. With these three elements, there can be elements like sulfur, nitrogen, phosphorus and halogen. So these elements can also be there with those three important elements. Right? Those three elements are, once again, carbon, hydrogen and oxygen. Fine. That's about the introductory part of this chapter, that is general introduction. Now let us see classification of these organic compounds. Classification. Classification means division. How these organic compounds are divided. These organic compounds sometimes look like the chain structures. Sometimes they look like closed structures, means ring structures. So based on this, whether they are closed structures or open structures, these organic compounds are mainly divided into two types. Organic compounds, they are divided into two types mainly. What are those two types? Number one is open chain compounds. Number two, closed chain or closed structures, we can say. Closed structures, open chain compounds, closed structures or compounds. They are also called ring compounds. And these open chain compounds, we don't have further classification in this, whereas closed structures or ring compounds are divided mainly into two types. That is acyclic, alicyclic compounds and aromatic compounds. Right? This will be one. Yeah. Next, these alicyclic compounds are further divided into two types. What are those two types? One is homocyclic compounds. Second one is heterocyclic compounds. These are heterocyclic and that too non-aromatic. And these aromatic compounds are divided into different types. What are those? Let us see. First one is benzenoid compound. Second one is non-benzenoid compound. And third one is heterocyclic aromatic compound. Right? That's about the division of organic compounds. So organic compounds mainly divided into two types: open chain compounds and ring compounds, or closed structures. Right? And these closed structures or ring compounds are divided into two types. Again, they are alicyclic compounds and then aromatic compounds. And these alicyclic compounds are divided into two types, namely homocyclic compounds, number two heterocyclic compounds. And these heterocyclic compounds are alicyclic type or non-aromatic. Right? Aroma means good smell. They don't have good aroma. And second type of ring compounds is aromatic compounds. All these compounds will have good aroma. Aroma means odor or smell. And these aromatic compounds are divided into three types, namely benzenoid compound, non-benzenoid compound and heterocyclic compound. Now we will see examples for each type. First one is open chain compound. Example for open chain compound is propane. CH3, CH2, CH3. Right? And we can write here even the prefix N, N-propane. N for normal. In chemistry, normal means one which doesn't have any branch. Next, example 2. CH3, CH2, CH3, CH2, CH3. Altogether we have 5 carbon atoms. So it is N-pentane. And these are nothing but the open chain compounds. We'll see one more. Look at this, CH3, CH2, no, CH, CH2, 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 CH3. And here I am adding Cl. This is also open chain compound. And here we have 1, 2, 3, 4, 5, 6 carbon atoms, right? And chlorine is connected to particular hydrogen atom. So we can write its name as 2-chloro. 3, 4, 5, 6. Hexane. Nomenclature was taught in class 10th, you recall. Okay. So when numbers are given, Cl will take the least possible number 2. Of course, I am going to teach this in detail. Why should we write name like this only? As and when the nomenclature of alkanes, that means hydrocarbons, are taken. That's about example for open chain compounds. And here I don't have space for writing example for closed chain compounds. So part of this I'll erase. Now let us see alicyclic compounds. In this we have two types. One is homocyclic compound and other one is heterocyclic compound. Homocyclic compound is one wherein in the what we call the cyclic structure will have atoms of same type. Atoms of carbon, atoms of hydrogen, right? So example for homocyclic compound is so this compound is known as cyclobutane. Right? Another example, this is cyclohexene. Right. Next, we'll move to heterocyclic compound. So here I don't have sufficient space. So here I write example for heterocyclic compound. Example for heterocyclic non-aromatic, it is compound, and that compound is cyclohydrofurane, and that compound looks like this. Right? That is example for heterocyclic compound. Now we will move to aromatic compounds. Part of this I am erasing because I don't have space to write the examples. Now look at aromatic compound. In that, number one, benzenoid compound. Benzenoid compound means that compound which contains at least one benzene ring. So example for benzenoid It is benzene, next, if we fuse two benzene rings, we will get naphthalene. Naphthalene balls. Usually these are kept in toilet rooms to repel the moths. And other example, wherein three benzene rings are fused with each other, and that is anthracene. So these are examples for benzenoid compounds. Now let us see non-benzenoid compounds. Example for non-benzenoid compound. Non-benzenoid compound is one which should not have benzene type of structure in it. Now let us see best example for non-benzenoid compound. This is non-benzenoid compound. You look at cyclohydrofurane. This is the structure of cyclohydrofurane, and here we have kept two pi bonds. So this compound has become now furane. That's all. And the last one is example for heterocyclic aromatic compound. Best example for this is pyridine. And this pyridine has benzene-like structure, right? And a particular corner where two bonds are joined, there we have nitrogen, right? And here we can show 1, 2, 3 pi bonds. Aromatic benzene, yeah, it is pyridine only. So that is about classification of organic compounds. Yeah. Now let us see, children, the second part, that is nomenclature of organic compounds. Nomenclature means giving name to the organic compound. On what basis the names were given very long back, once upon a time. Let us see. That time population was very less, so need of the compounds were also not that much. Therefore, based on the source which the compounds were obtained, they were given names. Now let us see example for such compounds. Example 1, citric acid. So citric acid is nothing but one organic compound, and this organic compound is obtained from citrus fruits. sour fruits. Right, this is one example. Example 2. Formic acid. And this is usually obtained from formicus, which means red ants. Means red ants were collected in large quantity and they are subjected to fractional distillation. As a result, this acid is obtained. And at the same time, there is an element that is Buckminster fullerene. Buckminster fullerene, that is C60. And here, like this, we have some more compounds like acetic acid that is obtained from acetone. So all these are common names, common or trivial. Names. But with increase in population, need of the compounds also increasing. Right now we have millions of carbon compounds, compounds containing carbon. Therefore, it is very difficult to give common name to such compounds. Therefore, a particular system is required to give the names to the compounds, and that system is nothing but IUPAC system. Right now we are going to see how the compounds are named on the basis of the norms framed by IUPAC. Now the third part is IUPAC nomenclature. Full form of IUPAC is International Union of Pure and Applied Chemistry. This has framed certain norms. Accordingly, the given organic compound is given the name. Now let us see the main things that are required before going to name the compound. Whenever a particular compound is given to us, we have to identify the parent hydrocarbon part of it. That is first one. Number 2, we have to find out whether to that parent hydrocarbon part substituent is attached or not. Number 2, whether that number 3, whether that parent hydrocarbon has any functional group, any way connected to any carbon atom of that parent hydrocarbon or not. Next, at the end, we have to find out whether we need to include prefix, suffix or infix. Prefix means one which we are going to add at the beginning of the name of the compound. Suffix means one which we are going to add at the end of the name of the compound. You recall the same points were taught when you were in class 10 in carbon compounds chapter. And infix means in between. Whether we are required to add infix in between the name of the compound or not. Prefix, infix and suffix. I'll give one example wherein substituent, functional groups and also the parent hydrocarbon can be identified in this way. This is one compound. Now look at this compound. In this compound, whenever any substituent or functional group is connected, or even hydrogen atoms to the carbon atom, we have to see that the valency of that carbon atom is always 4 because it is tetravalent. Right? It should not be 3 or it should not be more than 4. 5. When compound of this type is given to us, organic compound, and that too this is open chain compound. Right? This is open chain compound. Now, in this compound, this part is called parent hydrocarbon part. Now, this Br and OH and CH3. Remember, in any compound, CH3, C2H5, right, methyl, ethyl, propyl, they cannot be the functional groups. So, this is substituent. And Br is functional group. And OH is also a functional group. So this is what you need to remember, children. So in IUPAC nomenclature, the main part that is required to be remembered when a particular organic compound is given to us is how to identify the parent hydrocarbon. That is first point. Number 2, if any substituent or functional group or functional groups are connected, right? Here one thing is we should keep always in our mind which is substituent, which is functional group. These are very important, right? The concept of functional group was taught in class 10, you recall. So here in this example or in any example, when alkyl group is connected to parent hydrocarbon, alkyl group means it can be methyl, right? Its formula is CH3, and it can be abbreviated by ME for methyl. Number 2, ethyl, that is C2H5. Number 3, propyl, C3H7. Number 4, butyl, C4H9. Right? Means whenever we subtract one hydrogen atom or whenever we remove one hydrogen atom from any alkane, we will get concerned alkyl group. Alkane minus hydrogen atom is equal to alkyl group. That alkyl group can be methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, and so on. Next, meet means one carbon atom. Eth means two carbon atoms. Pro means three carbon atoms. Like that. But. We should not read this as but. In chemistry, this should be read as but. So but means four carbon atoms. Right? So this is what you need to remember. So alkyl group. How do we get alkyl group? By subtracting one hydrogen atom from alkane. So alkane minus hydrogen atom is alkyl group. Let us see example for that also. Alkane. From this, they are subtracting one hydrogen atom. Then we will get alkyl group. Now let us see example CH3H. This is nothing but methane. CH3H means methane. Now I will remove this hydrogen atom. As a result, I will get methyl group CH3 and one bond will be there. Means any atom with valence 1 can be attached to this. Now this is called methyl. Right? Now example 2. CH3 CH2 H. When this hydrogen atom is removed, this compound is ethane. When this hydrogen atom is removed, we get CH3, CH2 single bond, and this is called ethyl. So in that way, from ethane, when we remove one hydrogen atom, we will get ethyl. Now let us see example 4. 1, 2, let this be example 3. Look at this compound CH3, CH2, CH2, CH2H. This is called butane. But means 4 carbon atoms. So in this compound we have 4 carbon atoms. Now from this hydrogen atom is removed. Imagine this hydrogen atom is removed. Now butane becomes CH3, CH2, CH2, CH2 with single bond. So butane becomes butyl. Like that, from pentane, if we remove one hydrogen atom, we will get pentyl. Hexane, hexyl. Last example, CH3, CH2, 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 CH2H. Altogether in this compound we have 6 carbon atoms, so it is hexane. From this hexane, we can remove this hydrogen. As a result, we will get CH3, CH2, 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 CH2. 1, 2, 3, 4, 5. CH2 single bond. So this is hexyl. So all these methyl, methyl, propyl, butyl, etc. are nothing but the alkyl group. So alkyl group is formed when one hydrogen atom is removed from alkane. And thank you children.